Hello, in this video, we are going to talk about logarithmic differentiation. This is a technique used for finding the derivatives of functions like some function f of x to the power some other function g of x. So in these techniques, neither the power rule or nor the exponential rule works. So because this is not a power function or an exponential function, so the only way to differentiate these functions are used to logarithmic differentiation. So we can have functions like x to the x, sine of x to the x squared, or ln of x to the tangent of x. So what we do is we take ln of both sides. So ln of y equals ln of f to the g, but then we use the property of ln function, which is ln of a to the p is p times ln of a. So then this ln of f to the g will be equal to g times ln of f, and then we differentiate both sides with respect to x. So for the left hand side, we will have a chain rule for the derivative of ln of y. For the right hand side, we have product of two functions. So we apply the product rule for the right hand. And then we get 1 over y times y prime equals derivative like g prime times ln f plus g times derivative of ln of f. So for the derivative of ln of f, we use the same chain rule for the left-hand side. That gives 1 over f times f prime. So this is going to be the result. But then we want y prime, so we multiply both sides by y, and then that gives a simplification on the left-hand side. Y times 1 over y cancels, but to the right we have a multiplication by y. And then we write y back, which was f to the g. So this is the derivative of f to the g, this long expression here. Now let's do an example. For instance, let's find y prime if y is x to the x. First, we take ln of both sides, and then that helps us to take the power x outside of ln. So ln of y is equal to x ln of x, and then we take the derivative of both sides. For the left-hand side, the chain rule always gives 1 over y times y prime. For the right-hand side, there is always a product rule at first. So derivative of x times ln plus x times derivative of ln, which is 1 times ln x plus x times 1 over x. So that's going to be equal to ln of x plus 1. But on the left-hand side, we have a 1 over y. So we just want y prime. To get rid of that 1 over y term, we multiply both sides by y. So that y times 1 over y on the left-hand side simplifies to y prime. On the right-hand side, we have a multiplication by y again. Then we write y back, which is x to the x. And the final equation is the derivative we are looking for. Now, second example, find y prime if y is tangent x to the x squared. Well, we take ln of both sides. So that helps us take the power x squared outside of ln. So ln of y equals x squared times ln of tangent. And then we take the derivative of both sides of the equation. On the left, we have always a chain rule, and that brings 1 over y times y prime. On the right-hand side, we always have a product rule. So we write the product rule, derivative of x squared times ln of tangent plus x squared times derivative of ln of tangent. Derivative of x squared is 2x. Derivative of ln of tangent is 1 over tangent times derivative of tangent, but derivative of tangent is secant squared. So we multiply both sides by y. That gives us y prime, but y prime equals y times that expression in the bracket, but y is equal to tangent of x to the x squared. So that's the result. That's the final answer for the derivative. Another example. Let's say y is ln of x to the power sine of x. We want to find y prime. First, we take ln of both sides, so that helps us to take the power sine x outside of the ln and multiply. So ln of y equals sine of x times ln of x, and then we take the derivative of both sides. On the left, we always have, from the chain rule, 1 over y times y prime. On the right, we always have a product rule. So derivative of sine times ln of x plus sine times derivative of ln of x. So derivative of sine x is cosine times ln of x plus sine x times, now 1 over whatever inside the outside ln, so 1 over ln x times derivative of ln x, and that's equal to 1 over x. So we multiply both sides by y, so y prime equals, writing also y back, ln of x to the power cosine of x. Wait, that's ln of x to the sine of x. This cosine should be sine. ln of x to the sine of x equals cosine x times ln x plus sine x over x ln x. And then there is a remark here. This log differentiation is a general differentiation method. Well, it actually gives both the power chain rule and the exponential chain rule. So power chain rule is n times, like f to the n, derivative of f to the n is n times f to the n minus 1 times f prime. And for the exponential chain rule, we have e to the f, derivative of e to the f is e to the f times f prime. So we shouldn't confuse it with these rules. Because like if we have the confusion, let's do the power chain rule here, which will be, okay, take the power down, multiply by 1 less of the power, and then multiply by the derivative of x, which is 1, which is going to give e to x to the x again. But that's not the right answer. We just have found it. The derivative is x to the x times ln x plus 1. Okay. Or if we have just confused it with exponential, what is it going to be? Take the function back, x to the x, multiply by the derivative of x, which is 1. That also gives x to the x. Again, not right. Okay, because remember, derivative of x to the x is x to the x ln x plus 1 from the first example we have done.